It seems like there's no bottom to the topic of how to make Kafka cloud native. There's always some cool new thing to explore. Today I talked to Prachetaa Raghavan, who's an engineer who works on Confluent Cloud, about a recent blog post he wrote that's really about just how cloud native Kafka works, the control plane, things with Kubernetes, tiered storage, all the goodies. We're going to go through them all on this episode. Streaming audio is brought to you by Confluent Developer. That's developer.confluent.io. That's a learning website dedicated to teaching you about Kafka and Confluent Cloud. We've got video courses, patterns for event-driven architecture, executable tutorials, all kinds of things, really everything you should need to get started on your Kafka journey. When you sign up, you'll want to do examples and labs and things like that in the cloud, so use the code PODCAST100 to get an extra $100 of free usage. Now, let's get to the show. Hello and welcome to another episode of Streaming Audio. I am your host, Tim Berglund, and I'm joined in the virtual studio today by Prachetaa Raghavan. Prachetaa is a staff engineer here at Confluent. He's a coworker of mine, and he works on the cloud control plane team. So all kinds of cool things to talk about. He's also the author of a blog post relatively recently. We're recording this in the middle of November 2021. This blog post was like midsummer, end of July, I think. It was called Making Apache Kafka Serverless, Lessons from Confluent Cloud. Prachetaa, welcome to the show.
Thanks so much, Tim, for having me here.
You got it. So I want to talk through that blog post. There's a lot of really cool stuff in it. And you being an engineer on the control plane, you know things. And there are things that I think are just interesting to people who want to think about cloud services, people who want to deep dive on Kafka. There's just a lot to learn. But first, before we dig into that, tell us a little bit about you. You're a staff engineer here, but how'd you get into this role? What got you interested in this? Where are you coming from?
Yeah, absolutely. And it's kind of an interesting journey. So prior to Confluent, I was at a company called Delphix. It was a relatively smaller size company, probably at the time very similar to the size of Confluent. And when I moved to Confluent, I had no clue about Kafka or Kubernetes or any of the cool things. Yeah, so any of the cool things that Confluent is doing. So initially, I started out in the operator team at Confluent, which kind of dealt with how do you provision and deprovision or upgrade Kafka clusters in Confluent Cloud. And from there, kind of the journey took me towards different pieces in Confluent Cloud. I ended up being one of the people who also worked on Kafka expansions, which was a thing probably a year ago, and then Kafka Shrink, which is coming out soon. And then that's where like all of these lessons learned from how do you deploy and run Kafka in Confluent Cloud experience grew.
Cool. Shrink. Shrink we added later, right? We made it easier to make clusters bigger because it's usually what people want to do. And then later on, also if you need to make them smaller, that's okay too.
Yep.
Always harder to, when you talk to product management, harder to prioritize things like that for some reason. We're not sure why, but it's just about GA now, I think.
Yes, that's right.
Anyway, making Kafka serverless. I remember the first time I read the phrase serverless Kafka. It was when we started using that phrase here at Confluent. My first reaction was kind of like, what? Who came up with this? Serverless is about functions. Serverless is Amazon Lambda. And that's I think, the programming that a lot of us come to the table with. So yep. What does serverless mean? If it's a thing that can encompass Kafka, and by the way, anytime I talk to anybody on the show about something serverless, I ask them this question. And I think everybody has a different answer. But tell me, what is serverless?
Yeah, for me, serverless is basically as a user, I do not have to care about how you're going to run my application. All I have to care about is I have this piece of application or code that I want to run, and the infrastructure and all of the niceties is already taken care of. And I, as a user, also get billed based on how much I use, not pretty much like, hey, I have this much of bandwidth or the number of servers that I have to keep running for my application. It's like if a request comes along, you spin up, you run the code, and then spin it down. That's kind of serverless to me.
Gotcha. So keeping any concerns that could possibly be like infrastructure related concerns, keeping them out of your face and whatever the core abstraction is that the thing offers to the developer.
Absolutely.
Just offer that. So where it started was, throw a little piece of JavaScript at us, and when something happens, we'll invoke the function.
Yep, absolutely. And that was kind of my first introduction to serverless as well, which was AWS Lambdas.
Yeah.
And that was the perfect abstraction for serverless that I know of.
Yeah. But like a Kafka topic in the sky, where you don't know what a broker is, you don't know about scaling, these are not things you think about. That's the serverless Kafka idea.
Yeah, absolutely. And on the Kafka front, it's pretty much a lot of configuration, and it's a distributed system that you need to run. So running distributed systems, especially at scale, is pretty hard. And it's not just Kafka. There is Zookeeper as well that you need to run,
for now,
which is going away. But still, like right now, you do need to run both of them together. And if you can abstract out all of the complexities of running Kafka and the infrastructure, that's kind of the serverless, event-driven platform that Confluent Cloud offers.
Gotcha. And it is pretty cool because, like I said, I remember the first time I heard the phrase, I was skeptical. It sounded like somebody was trying too hard. But then once you think about it and you kind of free your mind from serverless equals cloud functions, you realize, no, there is a core abstraction in whatever the service is. It's a database. It's a distributed log. It's an application server. It's something, and that just exposing that, as it were, as an API with no infrastructure concerns visible to you at all is pretty powerful. So,
yep, absolutely.
Now, talk about how you guys do this. You, in the blog post, you talk about 4 components: the control plane, Kubernetes operator, self-balancing clusters, and infinite storage. Dive in. I mean, this is, maybe we could even just back up and start with Kubernetes, right? This is all based on Kubernetes and massive numbers of Kubernetes robots behind the scenes doing things.
Yep,
so
absolutely.
How does that help?
Yeah, so Kubernetes is kind of very critical to what Confluent Cloud offers. So let's maybe take the concept of a broker, and you're running it on either bare metal or even EC2 instances for that matter. If the broker goes down for whatever reason, you kind of need to have the whole alerting system, and you need to have everything in place to make sure you're able to recover from that scenario. Kubernetes it's a very simple container orchestrated platform, but it's very pluggable and portable. Like you can run Kubernetes on different machines. You can run it on your cloud, like AWS, GCP, Azure. All of them offer these natively, but they also offer a lot of niceties in there where you can scale up easily, scale down. And Kubernetes itself is kind of a reconciliation reconciliation system, wherein basically if an issue happens, it will try and recover that state automatically. So it's pretty much like you have a specification, you say, this is kind of my desired state. So it's kind of specifying the what and not the how. So as long as the what is specified, Kubernetes takes care of realizing that state to its end goal. And if there are any issues that it encounters, it'll kind of fix it itself.
And of course, there's lots of different kinds of whats that you might specify, and that makes the hows interesting because, like, a stateless application server type of code, or type of component, you can sort of stand those up and shut them down and move them around, and they're fine. But things with state, life gets harder, and there's lots of custom ways of doing the how.
Yep, absolutely.
So it's kind of, and this is a dorky analogy. And everybody listening to this knows what Kubernetes is, but it for infrastructure like this, for a cloud service like this, it's kind of like the distributed equivalent of an operating system. It's the way that the set of primitives that you use to spread your state and compute around your computing resources, to allocate computing resources to them.
Yep, absolutely.
I'm sure that analogy's been made before. Now that I'm thinking about it, I kind of like it. X is the operating system of Y is not always my favorite analogy, but that's kind of working. I'll think about that later. Anyway, control plane. Moving on to control plane. That was I think the first thing in the list in the blog post. Tell us what that means. If you're new to the term, what's a control plane? And walk us through the control plane in Confluent Cloud.
Yes, so control plane in Confluent Cloud, you can think of it as the central nervous system. So it has a lot of things that it does internally. So for example, one of the jobs of the control plane is also to expose all of the internal as well as external facing APIs for the customer. So when a customer comes along and says, "Hey, I want a 4CQ Kafka cluster
Mm-hmm.
in
A
XYZ,"
CKU is like just a unit of how big it's going to be for a dedicated cluster.
Yep,
It's like saying 4 brokers, but it's not saying 4 brokers.
Yep. So it's pretty much the job of the control plane to realize that state. So if you say, I want a 4CQ Kafka cluster in AWS in US East 1 or something of that sort, the control plane takes that request and then it kind of, you can think of it as, in Kubernetes analogies, it's basically going to realize that state. And some of the operations in the control plane are also like, some of the APIs that are exposed, which are, if you want to create an API key or if you want to delete an API key, all of those pieces are also involved and taken care by the control plane. And on top of this, there are certain internal things that the control plane does, which is like placement and capacity management, which is kind of transparent to the customer or the user. Like they don't know where we are placing things, how is our capacity managed internally. That's kind of all an internal function within control plane.
Got it. And so bringing Kubernetes back into the picture, Confluent Cloud exposes a user interface that is something like, hey, I want to create a new cluster. What type of cluster would you like? I'd like a dedicated cluster. Well, how many CKUs would you like? So you're saying how big you want the cluster in some kind of amorphous unit. That's a nice user interface for a fully managed Kafka, right? Mm-hmm. Writing YAML would be an example of a very, very bad user interface for a fully managed Kafka because it wouldn't be all that dang managed. So yep. You're saying it's the control plane that takes the nice user interface I see, just thinking of the case of cluster creation, and then turns that into Kubernetes API calls, basically.
Yeah, so pretty much. So control plane has to decide a few things. So if the customer says, you can place my Kafka cluster in this region, control plane has to also decide what is the size of the cluster, convert the whole CQ definition into like internal broker definitions, configure the whole Kafka cluster, and all of this is done through like a YAML specification. I know we discussed YAMLs, but internally Kubernetes is, you're specifying the what, you're not saying how. Mm-hmm. So you're specifying like, this is my Kafka cluster, these are my placements, this is the size of the storage, and so on. And that gets passed on to like the Kubernetes operator and gets realized into the Kafka cluster itself.
Now, you talk about how the Outbox pattern shows up in this process. And that's a helpful pattern. So number one, tell us, for anybody who doesn't know, what's the Outbox pattern and how does that show up in this flow?
Yeah, absolutely. So the Outbox pattern is, maybe we can take an example here. So let's say you're ordering something from Amazon or something of that sort.
That's unlikely to happen. Well, unlikely to happen while I'm recording this podcast, but daily activity. Go on.
Yep. So as soon as you make that order, it's basically like an order entry that gets created. Mm-hmm. But at the same time, you also need to update your inventory with like, whatever, X-1 because someone has ordered this product. And then you have to also ship the product and so on. So the Outbox pattern is basically as soon as the order comes in, you update the order table with saying this is the order and so on. But you also make an entry into a table called the Outbox table, which is then consumed by events and updated to other services. So you do it in a single transaction. You make an entry into your orders table. You also make an entry into your Outbox table. And then you have like a change data capture, which takes in entries. It looks at things in the Outbox table, or you can consider it as an events table. And then you can store it into Kafka. And then you have consumers from Kafka, which consume these events and process the new result out of it.
So you're transactionally changing state and creating an event that lets other consumers react. Have something to react to. Right.
Yep, that's right.
Gotcha. And how does that show up in the control plane?
Yeah, absolutely. So the control plane, like we mentioned, it translates the CQs into a Kubernetes CRD. CRD is a custom resource definition,
Hmm.
and that gets stored into the database in control plane. And then we have a similar pattern. We have the change data capture that looks at these tables, and then it pushes those events into Kafka. So we dog food Kafka internally as well. And then we have consumers, which is kind of the data plane. This is where like the customer clusters are running. We have consumers listening for these events. And as soon as it looks at like there is a CRD that I need to look at, it takes that and stores it into Kubernetes, which is kind of our data plane. And that's very similar to the Outbox pattern. It's not the exact pattern, but it's very similar to the Outbox pattern.
Cool. Cool. Now, let's see what's next in our list. You've got control plane, the operator. So what's a Kubernetes operator? And I have a sense of how that's going to plug in here, but tell us what one is and where that fits into Confluent Cloud.
Yeah. So a Kubernetes operator is a very application-specific controller whose main functionality is to extend the Kubernetes API in terms of like creations, configurations, and managing instances of your custom application itself on behalf of the Kubernetes user. So in this case, basically we're talking about Kafka. So the Kubernetes operator is responsible for realizing the state of the Kafka cluster. So we spoke about how like the CDC pipeline and everything gets us the Kubernetes CRD or the CR to be specific, like the custom resource. It's kind of an instance of the CRD. So once you get that, the goal of the operator is to realize the Kafka state. So the CRD, for example, says like, I want Kafka brokers of X size. It has the CPU specifications, memory, storage, and so on. It also talks about like, how do you, for customers who use their own keys to encrypt the storage, how do you configure the storage? The operator is responsible for doing all of that. And on top of that, it's also responsible for placement. So, if you create a multi-zonal cluster, you want to make sure the brokers are spread across zones and your replica placement is also taken care of. So our Confluent Cloud's Kubernetes operator is kind of responsible for, realizing all of these states.
Got it. So Kubernetes as this system that maps a declarative description of what you'd like onto those resources deployed out on actual computing resources needs the operator to know how to take this new kind of resource and make it a thing out in the world.
Yep.
Nice. Which, this message brought to you by Confluent Platform. That's Confluent for Kubernetes is used to be called Confluent Operator, but that's that whole thing that we had to build for Confluent Cloud, like extracted and productified. So if you productized, so if you run on-prem, you can kind of like extract some of this stuff that Prachetaa and team have built and use it in your own Kubernetes cluster. Now, self-balancing clusters. That was the third. I think we might get through this whole list. I'm feeling good about this. So we've got, so far, we've got just the control plane, the Kubernetes operator, self-balancing clusters, which sounds like a thing that would just be a feature of the operator, but tell me what they are and how they work.
Yeah, so self-balancing cluster is basically a feature of Kafka. So when Kafka realizes, okay, I have new brokers added to this cluster, it basically does a self-balancing call in the sense that it sees that these new brokers are not having any leaders or it doesn't have any replicas in there. So it thinks that it needs to rebalance the cluster so that the load is spread out across all brokers. However, it's a very complex feature. It's not just about like, for example, storage or replicas or something of that sort. It has a lot of other dimensions to it. Like it thinks in terms of leader counts, disk and network usage, and also looks at other constraints like what is the amount of available disk and network capacity when it does these balancing decisions. However, like prior to SBC is self-balancing Kafka, prior to it, the operator was the one that handled it. The operator, when it looked at these new brokers that came in, it used to tell Kafka, hey, you have new brokers, kind of initiate a rebalance to these new brokers. But since then, like Kafka has this inbuilt feature, so operator doesn't care about it anymore.
How much actual copying of log files is done? Because I mean, in principle, the task for keeping a cluster balanced is to move a partition from one replica to another. And so, how much actual bulk moving of files over network connections is done?
Yeah, so that depends on how the cluster is configured. And most of our clusters in Confluent Cloud have this feature called infinite storage. So when you look at it, the amount of data that's actually on those brokers is kind of a subset of the overall data. So it's basically like the shuffling is pretty small in terms of how much data is moved across the brokers.
So, and that actually is the next thing I wanted to ask you about. That's good, by the way, because that the bulk moving of data is expensive, right?
Yep.
There's all kinds of well, just like literally physical reasons why it costs energy and time to make that happen. We'd rather not do that if we could. So tiering is a nice way to keep the amount of data that you have to move smaller. But walk us through tiered storage. It's a super obvious idea, but it's only obvious after you've thought of it. So tell us what it is and how it works.
Yeah, so tiered storage is basically you have a second layer of storage for the Kafka brokers. So there's a hot set which is configurable, but then the hot set defines how much of data is actually in retention by the brokers themselves. The rest of the data then gets tiered to the secondary storage. And basically, for the most canonical messaging system, you basically are going to read your own writes as soon as it's written. Mm-hmm. But for the other use cases where you have to read historical data, it is fine. Like you do get those reads from the second tier of storage. But that's basically what is tiered storage in its whole entirety.
So the hot set, the first tier is log files on brokers. I mean, in serverless Kafka, we don't think of such things, but in fact, in the system you run, there are brokers and they have storage, and there are partitions that are kept by those brokers. It's Kafka. So that hot set, or the hot tier, the fast tier, is that regular thing. And the other one is like S3 or Azure Blob Store or something like that.
Yes, that's right.
Okay, and as a user, this being, again, serverless, I see a topic. I don't need to worry. I don't need to make a separate kind of API call to go to the blob store. It's just higher latency.
Yep. And as far as you're just producing and consuming data, and that's pretty much what you see as a user. But internally, Confluent does all of these magic, and it's just transparent to everyone.
Yeah, Confluent Cloud's doing a bunch of stuff. You're just using the same old producer and consumer API. And like you said, that latency hit isn't going to happen much because you're usually reading the hot set, unless you have some process that needs to go back, and in which case. And I've made the point recently, we've always done this, right? You've got processors that have a register file and cache and another tier of cache and then main memory and then a disk and then some tape thing, or even S3, right? S3 has tiers. There's the fast tier and there's the glacier tier that's probably on some tape drive that some robot picks out of a wall, you know?
Yep.
We always do this. There's a trade-off between latency and cost, and we're happy to make that trade-off.
Absolutely. And I think the other piece that goes unnoticed in here is also how it helps shrink overall, because in shrink, you're removing brokers, and then that means basically you have to also rebalance the data out of those brokers that are being removed to the remaining set. And since you only have a subset of data in the brokers, you can pretty much like add and remove brokers very quickly. So that's also a huge advantage towards this whole serverless Kafka ecosystem.
Yep. And once it's in the cloud, then it's in the cloud. You might as well take advantage of these things that are effectively infinite, right? You're not gonna. I was talking to Gwen Shapira. In fact, that episode may have aired in the last week or two before this one. I'm never. The order shuffles a little bit between recording and when they go out. But recently, Gwen's been on the podcast, and she made the point, you're not going to run out of S3, right?
Yep.
You're just not. Maybe you're big and cool, but that's not going to happen. So what do you see about the future? Like where does this all go? This seems pretty complete to me, but you talked about the future a little bit in the blog post. So where do you go?
Yeah, I think one of the things with serverless is if you look at, for example, AWS Lambdas, they basically shut down when you don't need them, and then they scale up when you do need them. We kind of are envisioning Kafka to be on the same, journey. We're not there yet. Customers can scale up, they can scale down now, but then you're not really scaling down Kafka to zero. Like, there's still compute there that's running, and you still have the data in there. We want to really see how we can realize that vision. Can we scale it down to zero? And resources are actually dynamically allocated based on workloads and policies. So this is kind of where we want to take the journey, where users only need to think about their client application logic, and Kafka resources are magically going to arrive when needed and disappear when you're not going to use them.
There's some non-obvious product thinking that has to go on there. There are interesting decisions, particularly about data, right? Because it's hard for that to scale to zero because you've got things stored.
Yep.
Where does that go? And there's a bunch of trade-offs. It'll be interesting to see how the team tackles that. And I'd like I'd like that fully managed Kafka even better.
Yeah, absolutely. And it's going to be an interesting journey. We'll see how we get there.
My guest today has been Prachetaa Raghavan. Prachetaa, thanks for being a part of Streaming Audio.
Absolutely. Thanks, Tim, for having me again.
Thanks for listening to this episode. Now, some important details before you go. Streaming Audio is brought to you by Confluent Developer. That's developer.confluent.io, a website dedicated to helping you learn Kafka, Confluent, and everything in the broader event streaming ecosystem. We've got free video courses, a library of event-driven architecture design patterns, executable tutorials covering ksqlDB, Kafka streams, and core Kafka APIs. There's even an index of episodes of this podcast. So if you take a course on Confluent Developer, you'll have the chance to use Confluent Cloud. When you sign up, use the code PODCAST100 to get an extra $100 of free Confluent Cloud usage. Anyway, as always, I hope this podcast was helpful to you. If you want to discuss it or ask a question, you can always reach out to me at tlberglund on Twitter. That's TLBERGLUND. Or you can leave a comment on the YouTube video if you're watching and not just listening, or reach out in our community Slack or forum. Both are linked in the show notes. And while you're at it, please subscribe to our YouTube channel and to this podcast wherever fine podcasts are sold. And if you subscribe through Apple Podcasts, be sure to leave us a review there. That helps other people discover us, which we think is a good thing. So, thanks for your support, and we'll see you next time.